Hello my dear VLSI aspirants, welcome to Deep Silicon VLSI YouTube channel. Let's start regarding 1's complement in single video. Yes guys, this video gives you the clear representation regarding 1's complement. Let's see the question. Which one of the following is the correct answer when 11011 base 2 is subtracted from 11101 base 2 by using 1's complement method? There are the options. Guys, first of all, there is one decimal number. How you can represent in 1's complement we need to know, because this is 11011 in 1's complement. What is the decimal number? You should know. For that reason, let's have this. For example, it is plus 6. Then the procedure is, we want to represent the plus 6 using 1's complement representation as, first you convert this 6 into binary, that will be 110, and you use the sign bit. Sign bit is 0. This is sign bit and that is magnitude. That's it. Sir, it is 1's complement. No, you need to apply 1's complement. No. In 1's complement representation also, for positive numbers, you need to represent the magnitude including the sign bit. We know sign bit is 0 for the positive numbers, 1 for negative numbers. It is plus 6 only, and it is 0, 1, 1, 0. If at all they want to represent the plus 6 using 6 bits, let's assume, then the magnitude bits take 110, the sign bit 0. In between the sign bit and magnitude bits, you can add any number of 0 as per your requirement. You want to convert these 4 bits into 6 bits, right? Then add 2 bits, this one, so that now you got 6 bits. This is the 1's complement representation of plus 6 using 6 bits. This is about a positive number. Let's have minus 6. Minus 6. For negative numbers, there are 2 steps, not 1 step. The first step is, including sign bit, you represent the plus 6. Yes, that is, it is minus 6 only, but in step 1 we represent using plus 6 only, that is 110. Let's assume with the 6 bits, so that this is 0 sign bit and it is 2 more zeros. This is magnitude bits, this is sign bit, and we added extra 2 bits because we want to represent in 6 bits. Then step 2, you applied 1's complement for this sequence. Yes, therefore it is 100, 111. For minus 6, it is 2-step procedure. Step 1, you need to include with the positive bit only, positive number only, it's a plus 6 you need to represent. And then in step 2, you need to apply 1's complement. Now we understand how you can convert a positive number or negative number using 1's complement. This is the sequence. Now you tell me, this is 111011. It is a number 11011. How you can convert? Very simple. In this way, you want to convert a 1's complement representation into a decimal number, because you want to know what is the decimal number. The procedure is, first you check MSB. If MSB is 1, it's a negative number. You want the decimal value, apply 1's complement again. Therefore, you will get the decimal value. Here, MSB is 1, means it is a negative number. You want to get the original value, convert into again, apply 1's complement. Therefore, 00100. Then obviously guys, what is a decimal value? You convert into decimal, you will get minus 4. So guys, this 11011 is minus 4. Now you understand how to convert a 1's complement representation into decimal representation. Similarly, you take this one, 11101. What is the decimal representation? The procedure is check MSB. If MSB is 1, it is a negative number. If it is a negative number, apply 1's complement again and convert it into decimal. That's it. So 1 MSB is 1, hence it is a negative number. You convert it into 1's complement, 00010. That means if you convert it to decimal, you will get -2. Hence guys, the 11101 in decimal representation is -2. Got it? Yes, you can ask me, sir, there is a sequence where MSB is 0. Then what to do? Simple. If you take any one sequence, for example, 0011, they said this is the ones, it is in the ones complement representation. Calculate the decimal value. Simple. Take the MSB. If MSB is 0, it's a positive number. Then simply you convert it into decimal. That's it. Hence the answer will be +3. That's it. This is the procedure because we studied already. In positive number representation, we didn't apply 1's complement. That's why when you are converting back into decimal, don't apply to 1's complement. Similarly here, for negative numbers, we applied 1's complement. That's only the reason. During the vice versa, when you are coming from the 1's complement to the decimal, we applied 1's complement. That's it. So now let's get back to the question. There is a number 11011 which is -4. We want to subtract this number from this number which is -2. Hence it is like -2 minus of -4. Then guys, what's the number? It is +2, isn't it? Yes. So we understood the decimal value will be +2. Now what will be the representation in this way? We want to find out. Let's do this first of all. Guys, here the procedure will be like, we want to do this as, let's assume this is, let's Minuend, okay, which is 11101. And this is Subtrahend. You need to use proper terminology guys, especially in interviews. Okay. Now Subtrahend is 11011. They asked us using the subtraction using 1's complement. The procedure is simply you convert this Subtrahend again into 1's complement and you can add it. That's it. So let's take this 11101. If you apply 1's complement here, so that you will get 00100. Now you add it 10011. Here again 0 and here it is 1. Then it is 0 and the carry 1. This is what we got when you do 1's complement, that subtraction using 1's complement. Now this one we call it as end around carry. In a short form, it is called like EAC. In this 1's complement procedure, you need to add this one to the least significant bit. Then let's get back to this here, it's 1. Then it is 0, carry 1. So it's 1, 0, 0, 0. So finally guys, here what we got the sequence when you do subtraction using 1's complement, that is 00010. Hence here you can say this is -2. This is -4. And we subtracted, we got +2 only now. Yes, this is the sequence. +2 in like 1's complement representation. What is the procedure? Very simple. You want to represent in 6 bits? Okay, 5 bits? Fine. Let's take 1 0 is the magnitude bits, sign bit 0, include any number of zeros in between. I want in 5 bits representation. Take 0 0. So you got the same, right? So it is plus 2 only. Everybody guys, here I'll tell you few more points. Don't skip the video. Coming to the point, here whenever you get the end around carry, remember the result is positive. If you get the end around carry, it represents it's a positive number, and you need to add this one to the least significant bit. Sometimes you don't get the end around carry. Yes, you want to see the example? Let's take the same example. I want to subtract now this number from this. Actually it is 2 minus of minus 4, right? Now I want to do minus 4 minus of minus 2. Then what you'll get guys? Minus 2 only, na? Now let's see the same here. It is like the minuend has changed. What is that? It is like this one. It's 1 1 0 1 1. The subtrahend, this is 11101. I am taking directly. Okay, let's do this. I want to subtract, but they said using 1's complement. Hence the procedure will be like 11011. Apply 1's complement to this so that 00010. Yes, we applied again 1's complement. Now you do addition so that 1 0 carry 1 1 1 1. Guys, did you get the carry? No. If you don't get the carry, remember the result is negative. Now if you get the, if you don't get the negative, that represents a negative number, but I want the answer right. Usually what is this? You took this one only, na, which is minus 4, and this is minus 2 in 1's complement representation. Now for this, let's consider the answer. You should get minus 2 only, na? Yes. For this minus 2, MSB is 1. Wherever you don't get the end around carry, let's consider it's a negative number. And you want answer, right? This is not the final answer. You want to get the final answer, apply 1's complement again. Therefore, here if you apply 1's complement, 0 0 0 1 0. That's what here 2. So you don't get the end around carry, it's a negative number. You want to get the final answer, again apply 1's complement. Therefore you get 00010, it's 2. This is what about completely regarding 1's complement representation. How you can convert into a given decimal number into 1's complement. If it is represented in 1's complement, how to convert into decimal? When you do subtraction where minuend is greater than subtrahend, subtrahend is greater than minuend. What are the possibilities? When you don't get the end around carry, how you can represent? When you get the end around carry, what is the description? And now what you need to do with the end around carry? All these things in a single shot, single video. Hope you like this video, and if you really understand this video very well, please subscribe our channel Deep Silicon VLSI. Right? See you soon in the next video. This is Shivaram signing off. Jai Hind.